so we're going to go over our next basic property, or our next property of logarithmic functions. Okay, and it's called the power rule. And I like this rule because it simplifies everything that's related to when you see an exponent with logarithmic functions. Okay, it'll make more sense when we go over it, but this is a great rule to know because it'll simplify your life a lot. All right, so it's called the power rule. All right, say we have just a standard logarithm, log base a of x, and what I'm basically going to do first is put this into the inverse of the exponent function first. So if you remember, I'm going to raise both of these sides. I'm going to take a and raise them to whatever's on each side. So I'm going to raise this side a to the y, and if I raise this a to the log base a of x, I'm just going to end up with x. Okay? Now what's great with the power rule is if this x is raised to some power. So what I'm going to do to show that is raise this x here to the n power. So I'm just going to do x to the n, and what you do to one side, I raise this side to the n power. I have to raise this side to the n power as well. So now it's a to the y to the n. Now if you remember your basic exponent rules, you know that if you take an exponent and you raise it to another exponent, it's the same thing as just multiplying these two exponents together. So we have y times n. Okay? So from here, I'm going to take the log base a of this side and take the log base a of this side. Alright? So I'm going to do log base a of y of a to the y n, y times n power, and then I'm going to do log base a of x to the n power. Okay? So first thing we're going to do here is we know based on our basic properties of logarithmic functions is this would cancel out. This log base a and this base a would cancel out, and then this yn would just drop down. So you have y times n equals log base a of x to the n. Now here's where power rule gets really powerful. Okay, whenever you see a log base a of x to the n, so you have this n power here, there's a way of simplifying it. That's what we're going to do right here. It's y times n. Well, y is equal to log base a of x. So what I'm going to do is substitute this in for y. And then it kind of all makes sense from there. And then you have to multiply it by the n. So what I'm going to do right here is do n times, it's y, but it's log base a of x. So log base a of x, just like so, equals, and I'm just dropping this down, log base a of x to the n power. And here is where we get to the beauty of the power rule. Okay, anytime you see a log base a of x to the n at this n power here, if you want to simplify your life, all you got to do is take this n and put it in front and multiply it by log base a of x. And that's what we basically did here, if you can see. N times log base a of x. You just take that n and put it in front. Okay? So that's the beauty of the power rule. You're going to be using it on some of the problems, so make sure you understand it. You don't necessarily need to understand this proof, and for my class anyway. I'm never going to ask you about the proof, but you are going to have to utilize the power rule when you're solving logarithmic problems. Okay? So let me know if you have any questions on how to use this. Hope that makes more sense.